like the substrate that the cells use. So yeah, and of course I also looked into patents, and I'm not gonna read this out to you, because patents are part of a patent, but it was filed in, I think, 2011, and I was really surprised because it describes basically ethanol extraction. So to me it seems like a very weak patent, because they just describe that you can extract violacin using a certain extraction method that is either acetone, ethanol, methanol. That's like, to me, that's common knowledge. It's obvious, but in a way, they did get a patent for it. And the nice thing is they have many examples in the patent of how the patent works. So these are basically, they read like recipes. You can derive your methods from that. And I don't think they will ever sue you when you copy it, because it's so generic, it's so obvious that, maybe if you do the exact same thing, that they will have something against you, but otherwise, I would just go for it. So the bottom line is, when you fill in the canvas for the Enanthiobacterium, it does need oxygen. Oh yeah, and in this article where they put the cotton cloth into the bottles, they found that it was actually going faster without light. So you don't need light. In the bottles they place 330 milliliters, so I would also do that. They were growing on nutrient broth with some glycerol, some tryptophan. You can wait for 48 hours, then you should already see the pigments. You don't need to stir it. They didn't do that, at least. They didn't mention anywhere at how much bacteria they start in their reaction, so I would just assume 1 milliliter, maybe that's enough. And there's also no special mention of the pH that you need, so I think you can just go with the pH that you get from producing nutrient broth. And they said they were growing at 15 degrees, so yeah, you can fill all of that in. And of course, I also found lots of articles where they try to genetically modify other bacteria to produce violacin. So there are already constructs known for a genetic construct that you can introduce to, for example, E. coli, and then E. coli also starts producing the same pigment. And then in this graph you see the genes for that, but they also have red crosses through other genes, and those genes are responsible for the breakdown of tryptophan, and they try to knock that out into E. coli and to make an optimized